Today, we're going to learn about the properties of equality and identity. Now, a lot of these properties you should already know from pre-algebra, so I'm going to go through them relatively quickly, but you'll still get the main idea. So the first is reflexive. The reflexive property states that any quantity is equal to itself. This property is pretty self-explanatory in that the simplest example would be 5 is equal to 5. Because 5 and 5 hold the same value, of course they'd be equal to each other. And you can create larger expressions like 10 plus 3, and of course this would be equal to 10 plus 3. The second property is the symmetric property. If one quantity is equal to second quantity, then the second quantity is equal to the first quantity. So how can we see this visually? Let's say we have 5 is equal to 3 plus 2. If 5 is the first quantity, and 3 plus 2 is the second quantity, this is saying that the second is equal to the first. And so you'd write the second first. So 3 plus 2 is equal to 5. And this holds true. So the symmetric property states that 5 being equal to 3 plus 2, this is equivalent to 3 plus 2 is equal to 5. The third property is the transitive property. This one states that if one quantity equals a second quantity, and the second quantity is equal to a third quantity, then the first quantity is equal to the third quantity. So it's saying if A is equal to B, and B is equal to C, then A is equal to C. So let's say that 3 plus 5 is equal to 8. And let's say that 8 is equal to 2 plus 6. So this is saying that the first quantity is equal to the second quantity. And if the second quantity is equal to the third quantity, then the first quantity is equal to the third quantity. So if we write this out, 3 plus 5 is equal to 2 plus 6. And this holds true as 8 is equal to 8. Now the last property of equality is substitution. We've already worked with this property. This states that a quantity can be substituted for its equal in any expression. Sounds confusing, but let's just say x is equal to 3, and we have an expression that is 4 plus x. And we're trying to find the answer. Well, we know x is equal to 3, so we can rewrite this as 4 plus 3, which is going to be equal to 7. And so 7 would be our answer. So all we're doing is substituting x into the equation to solve for the answer. Now let's get into our properties of addition. The first one is the additive identity. This states that for any number a, adding 0 to it results in a. So let's say the number in question is 4. 4 plus 0 is equal to 4 still. If our number is 33, adding 0 still makes it 33. 0 does not affect the value of the given number a. Our second property of addition is the inverse property. This states that a number a, again, added to its opposite, so negative a, would result in 0. So if we took 5 and added negative 5 to it, this would result in 0. If we took 33, again, and took the opposite, which is negative 33, this would result in 0 as well. Now time to get into our multiplication properties. First is the multiplicative identity. This states that for any number a, multiplying it by 1 results in a. 5 times 1 is still 5. 33 times 1 is still 33. So 1 does not change the value of a for whatever value a is. Next up is the multiplication property of 0, which states that for any number a, multiplying by 0 is equal to 0. So a times 0 is 0. 5 times 0 is 0. 33 times 0 is 0. Anything multiplied by 0 is going to be 0. Finally, the last property is the multiplicative inverse property. This one states that for every number a over b, where b cannot be 0 because otherwise dividing by 0 is not possible, there exists sum b over a, to which the product of a over b and b over a is equal to 1. Let's say our a over b is 3 over 5. It states that there is a number to which if we multiplied 3 over 5 with this number, sum b over a, we would get 1. Now we know 3 is equal to a and 5 is equal to b. So b over a is the inverse of 3 over 5, which means the numerator and denominator are flipped. So what does this look like? Well, it'd be 5 over 3 instead of 3 over 5. And if we multiply across, we get 15 over 15, which is indeed 1. So it's saying for every fraction, multiplying it by its inverse is going to result in 1.